What's up everyone, welcome back to my channel. Today we're going to take a look at the problem on the board, which says consider a function f which is from the domain the integers z to the whole real line that's defined by f of x is equal to x, which you can kind of think it as an identity function, but it's not because the domain and the codomain are not the same. Okay, so here we need to actually consider the right hand side here as our condition with the standard topology. So the question is this function f continuous? So let's take a look at what we actually have on the graph. If we try to make a graph, suppose that the function is from the real line to real line, then of course it will just be a straight line, or to the straight line like this. Okay, for the y value and the x value down here. So this is the f of x, where the domain and the codomain are both the real numbers. Now, when we change our domain into just the integers z, we now can only define the x values when the x values is an integer. In other words, if we don't have x being an integer, there is no meaning for f of x. So if we only look at the integer parts, we of course will just get, instead of the red line here, we only have some dots. And in fact, it is still infinitely many dots here, but it will look like that it is not continuous anymore because we don't have line connected between the dots or between the points here, or you can think that for the two outputs, there is nothing in between that actually connect them, as we can actually draw it on a line like this. Okay, so here I'll let you guys pause the video and think about it first, whether or not this function is still continuous or not. Okay, and when you're ready, you can just move on and we'll see the answer. Okay, so in fact, this function f here that is defined from the integers to the real numbers is still continuous based on the standard topology that we have. So what is topology? I'll actually try to skip it, and if there's time, I might try to make another video about what topology is and give a basic definition. But here comes the definition in topology of what continuous function is. Okay, so if you have already taken real analysis course, you perhaps might know the definition of what a continuous function is using delta epsilon method, which says that f is continuous defined by for all epsilon greater than 0, there exists a delta that is also greater than 0, such that whenever the input of x in the function and delta let's call it x naught for some point, is less than delta, then we imply that the output will be always less than epsilon. Then we will say that the function f will be continuous at the value at x naught. Okay, then it has to satisfy for all x naught in order to have the function f to be continuous everywhere. But this is only defined, and it will only work for real lines or something that that contains real lines. And that's because this cannot be defined if we have something that is when the domain itself is not even it's not it's not compact or it's not connected. Then if we try to look for a more complete definition for continuity of a function, here is how we define a function being continuous in topology. So generally speaking, we will say that the function f is continuous by defining that for all, let's call v as as subset of the codomain here. Let me use it this way, codomain. Is open. So in other words, for all open sets V in the codomain, the inverse image of that open set, which you can name it as U, that is actually contained in the given domain, is also open. Then we will say that the function is continuous. So an easy way to think of it is, here we have the codomain to be the real number. So with the standard topology, it means that when we say open sets, it will just be how we define it regularly, such as an open interval. Then now what we need to do is we need to pick an open interval, any random open interval that we have. Let's say here, that actually contains not including this point here, like this. Then what we need to do is, now we need to check whether the image of this open interval here, in other words, if this part here is actually an open set in the given domain here. But here is another thing that we actually need to know. For the set of integers in the standard topology, we actually would say that for all elements that contains in the integer set, one single element itself is already considered as an open set. And therefore, no matter how we pick, we will always be able to get the preimage being an open set, because if we have the preimage being the union of two or more open sets, it will still be an open set. And again, that's just because of how we define it in topology, and again, it is a topological idea. So here is the result for this problem here. This function f, which is defined as f of x equals x, is in fact continuous under the condition that we have, which says that the function is from the integer to the real line with the standard topology. Although graphically speaking, it looks like that they're discontinuous everywhere because there's no connection. So when we are trying to think of these kinds of problems with advanced math level ideas, we now can no longer just simply rely on the graphs that we have, and sometimes we will actually get some ideas that are actually quite counterintuitive, such as this problem. Alright, that's it for today's video. I hope you all enjoy it, And don't forget to like and subscribe to my channel so that you can also find out more of my other videos. And don't forget to turn on the notifications so that wherever you have I have a new video, you won't miss it either. And if you have any thoughts, you can leave your comments down below. I'll see you guys next time.